Here is our problem. It says consider the voltage divider circuit shown in figure 1 right over here, where V1 is 9 volts, so we can write that here. 9 volts, and R1 is 500 ohms. 500 ohms. What value of R2 right here will give a value of 2 volts for V2? So if we tap into here, this point, with a voltmeter, say like this, voltmeter, we want that to read 2 volts. So how big should we make R2? Okay, well, this is just a standard Ohm's law, simple Kirchhoff's voltage law problem. So let's do the first thing. This is usually what we do for every problem. We find the equivalent circuit. Find the equivalent circuit, and we can just by inspection see that these are two resistors in series. So we know that the equivalent circuit is equal to, our equivalent resistance is R1 plus R2. Second thing is find the current leaving the battery. Okay, and we know that when we find the equivalent circuit, we're effectively taking the circuit and we're making it look like this, where this is R equivalent and this is V, and our current comes out here. And so we know that the current is just the voltage divided by the equivalent resistance. So the current is equal to the applied voltage divided by Req, and therefore I is equal to the applied voltage divided by R1 plus R2. Okay, now V2 we can find by noticing that the voltage drop between V2 and ground, which is right here, is just the current flowing through it, which is I, times R2 by Ohm's law. So almost by inspection we can say that V2 is equal to the current flowing through R2 times R2. So it's equal to R2 over R1 plus R2 times the applied voltage. So it'll get modulated depending on the values of R1 and R2. Alright, well, we've got our equation here. So we know V, and we know R1, and we know V2, right? This is 2 volts. This is 9 volts. R1 is 500, so we have to solve and isolate R2. So this is just a simple algebra 1 problem. So if you're more comfortable, you can replace R2 by X. I'm not going to do that here because I want to develop the ability to work with other variables. So let's just go ahead and rewrite the equation. V2 is equal to R2 divided by R1 plus R2 times V, and we want to solve for R2. So we have to do some algebra. So the first step, okay, we'll take it kind of step by step. So we're going to multiply, let's just rewrite it again, R2 times, or V2 times, is equal to R2 over R1 plus R2 times V. Okay, let's multiply both sides by R1 plus R2. Okay, so I'm going to do that here. I guess I'll just R1 plus R2, whole thing. So on the left hand side I'm going to get V2 times R1 plus R2, and on the right hand side this is going to cancel the R1 plus R2 upstairs and downstairs, so I'm just going to have R2 times V. Okay, well, let's just multiply through using the distributive property here. V2 times R1 plus V2 times R2 is equal to R2 times V. Alright, we're getting closer. Let's collect the R2s. So let's take this guy over here. So I'm going to subtract R2 times V from both sides, and so I'm going to get V2 times R1. That term doesn't change. V2 times R2 minus R2 times V is equal to 0. And now I can collect up the R2 terms. V2 times R1 plus R2 times V2 minus V equals 0. And I've got R2 isolated. I just need to I've got R2 identified. I need to isolate it. So I'm going to take this guy to the other side. So I'm going to have R2 times V2 minus V is equal to minus, because I got to take that to the other side, so it becomes negative. V2 times R1, that's that term. Okay, so I think I'm there. R2 is equal to minus V2 times R over V2 minus V. But in general, we don't want to have a negative out there in front. Why not just get rid of it? So I'm going to multiply the top and the bottom by -1. So that's going to make the top now positive, and it's going to reverse here, these two. I'm going to have V minus V2. So let's see what we get here. Oh my goodness, no. 2 times this is R1, and I'm sorry, this is 1. Sorry about that. Okay, let's put in the values. So V2, we want that to be 2 volts. R1 was 500 ohms. And then V is 9 volts minus V2 is again 2 volts. So I'm going to get 2 over 7 times 500 ohms. And that's going to give me R2 142, well, we'll say 143. It's about 142 and 0.85. All right, so a simple application of Ohm's law, and this is really the algorithm we have here for just about all the problems, and then we just have to do a little extra algebra to get the answer right here.